Good day, everyone! Welcome to Elementary Statistics and Probability class. We are now on week 6. Let us first have our learning objectives. First is to compute expected value and variance of a probability distribution and determine whether a probability experiment is a binomial random variable. And our lesson for today is all about discrete random variable and its probability distribution.
Discrete random variable and its probability distribution. What is random variable? A random variable is a variable whose possible values are determined by chance. It is typically represented by an uppercase letter, usually x, while the possible value is represented by lowercase x. A random variable is the result of chance event that you can measure or count. For example, x is equal to number of heads in tossing a coin thrice. The possible values are x is equal to 3, x is equal to 2, x is equal to 1, and x is not equal to 0. Random variables have two types, which is discrete random variables and continuous random variables. Discrete random variables is a variable that can only take a finite or countable number of distinct values. Kaya pa itong bilangin. Note, the possible values are 0 and positive whole numbers only. Yung mga possible lang ay 0 at positive numbers, bawal ang negative. For example, let's see is equal to number of defective light bulbs among the randomly selected light bulbs. The possible values are z is equal to 0, z is equal to 1, z is equal to 2, and so on. The next is continuous random variable. It's a variable that can only take an infinite number of values in an interval between two specific values, which is uncountable number of values. Note, the possible values can be represented by non-negative whole numbers, fractions, and decimals. For example, let x is equal to the weight or in pounds of randomly selected students. The possible values are x is equal to 100.85, x is equal to 150.5, x is equal to 170.75, and so on. Discrete probability distribution, or DPD. A listing of all possible values of a discrete random variable along with their corresponding probabilities. It can be represented in tabular, graphical, or formula form. Tabular, rows and columns. Graphical, probability histogram. Formula, probability mass function, or PMF. Discrete probability distribution is tabular graphical formula. It is formula or the functional form of representation of discrete probability distribution. It is usually called as the probability mass function, or PMF. So, this is discrete probability distribution. Yung x sa taas, that is the possible values, while the p of x, that is the corresponding probabilities. Then, on the table, that is the example of tabular. While in graphical is in the graph, and in the right side sa baba is example yung formula. Properties of discrete probability distribution. There are two properties that must be satisfied by a discrete probability distribution. Number 1, the probability of each value is between 0 and 1 inclusive. The sum of all probabilities is equal to 1. P of x is equal to 1.
Example number 1, the discrete probability distribution in tabular form. Consider the following table. The value of x are 0, 1, 2, and 3, and the probabilities are 0.2, 0.3, 0.3, and 0.2. The table shows DPD or discrete probability distribution because it satisfies the two properties. First, probability of each value is between 0 and 1. Second, sum of the probabilities of 0.2, 0.3, 0.3, and 0.2 is equals to 1.
So, in these slides, satisfies the two properties. First, the probability of each value is between 0 and 1 inclusive. And the second, the sum of probabilities is equal to 1. Probability histogram. The graph representation of discrete probability distribution. Ito yung naka-graphical representation ng discrete variable distribution. The values are set or written on the horizontal axis. The probabilities are set or written on the vertical axis. Rectangles are used to construct the histogram and the values are placed on the center of each bar. The probabilities serve as the height of each bar. As you can see, as the right side, yung pataas is the P of X or this is the corresponding probabilities. While dun sa baba naman is yung X or the values. Example 1, construct the histogram of the following table. Giving you sa table yung values of probabilities. Then check yung graph. As you can see, the left side is P of X while yung values ay nasa baba or naka-horizontal. Then, the given values for this problem is 1. Construct the histogram of the following table. So, may table ulit tayo. Then, yung X is 1, 2, 3, 4, P of X, 1/4, 1/4, 1/4, 1/4. Then, we need a histogram to summarize the data presented and to have this value.
Next is the third representation form of discrete probability distribution, the functional form, but usually called as a probability mass function or PMF. Probability mass function is formula form representation of discrete probability distribution. Like the example function above, f of x is equals to 0.2 if x is equals to 0, 0.3 if x is equals to 1, 0.3 if x is equals to 2, and 0.2 if x is equals to 3 or 0 otherwise. The PMF of x is denoted by f of x. It is usually represented by P of x is equals to f of x. And there are two properties that the probability mass function must satisfy. First, all probabilities must be a positive. It can be less than or equal to 0. Second, the sum of all probabilities must be equal to 1. Like in the example above, the probabilities 0.2, 0.3, 0.3, and 0.2 is equals to 1.
Discrete probability distribution in functional form. X is equals to 0, 1, 2, 3. P of X is 0.2, 0.3, 0.3, 0.2. In f of X is equals to 0.2 if X is 0, 0.3 if X is equal to 1, 0.3 if X is equals to 2, 0.2 is if X is equals to 3, 0 otherwise. Otherwise means if the value of X is not one of these values, then the chances or the probability is equals to 0. So that is the meaning of the otherwise. Or f of x is equals to 0.2 if x is equals to 0 or 3. 0.3 if x is equals to 1 or 2, 0 otherwise. Example number 2. Construct the probability mass function of the following table. X is equals to 1, 2, 3, and 4. And the probability here is all 1/4. The PMF will be f of x is equals to 1/4 if x is equal to 1. 1/4 if x is equals to 2. 1/4 if x is equals to 3. 1/4 if x is equals to 4, 0 otherwise. Or f of x is equals to 1/4 if x is equal to 1, 2, 3, or 4, 0 otherwise. Mean or expected value of a random variable. The mean of a random variable x is also called expected value of x. Value of x is x sub 1, x sub 2, x sub 3, and so on, x sub n. And the probability is p sub 1, p sub 2, p sub 3, and so on, p sub n. The mean of x is defined to be the product of x sub 1 and p sub 1 plus the product of x sub 1, 2, and p sub 2 until the product of x sub n and p sub n. Or we can just say the summation of x of the product x sub 1 and p sub I with the 1 as the lower limit and n as the upper limit. Variance of a random variable. The variance of a random variable displays the variability or the dispersion of the random variables. It shows the distance of a random variable from its mean, denoted by the deviation squared value. The variance of x is defined to be the variant is equal to quantity x sub 1 minus means value quantity raised to 2 times p sub 1 plus quantity x sub 2 minus means value quantity raised to 2 times p sub 2 until plus quantity x sub n minus its means value raised to 2 sub 2 times p sub n, or simply the summation of quantity x sub 1 minus its means value quantity raised to 2 times p sub I. We have 1 as the lower limit and n as upper limit.
So, let us first have an example of calculating the mean or the expected value and the variance of a random variable. Saver's production line produces a variable number of defective parts in an R with probabilities shown in this table. The value of x are 0, 1, 2, 3, and 4, while the probabilities are 0.15, 0.30, 0.25, 0.20, and 0.10 respectively. First, let us compute the mean or expected value. Remember that in calculating the mean, we are also looking for the expected value. Mean or expected values formula is represented as mu sub x is equals to the product of x sub 1 and p sub 1 plus the product of x sub 2 and p sub 2 until the product of x sub n and p sub n, or the summation of the product of x sub I and p sub I as I goes from 1 to n. So, using the values and probabilities, mu sub x is equals to the product of 0 and 0.15 plus the product of 1 and 0.30 plus the product of 2 and 0.25 plus the product of 3 and 0.20 plus the product of 4 and 0.10 is equals to 1.8. Next is calculating the variance of a random variable. Noting that the mean is equals to 1.8, We must calculate the variance by using its formula. Sigma squared sub x is equals to the squared of x sub 1 minus the mean times p sub 1 plus the squared of x sub 2 minus the mean times p sub 2 plus until the squared of x sub n minus the mean times p sub n, or we can say that as the summation of the squared of x sub I minus the mean times p sub I. Substituting all the values, and we can get the variance of 1.46. So, using the value of mean and the variance, how do we interpret the mean and the variance of a random variable? Saver's production line produces an average of 1.80 defective parts per hour. The number of defective parts variation is 1.46.
What is binomial random variable? Binomial random variable is a specific type of discrete random variable. A binary variable is a variable that has two outcomes. Example, sex, which has female or male, and then having a tattoo, yes or no. There are certain kinds of random experiments that give rise to a binomial random experiments, and we call these random experiments a binomial experiment. What is binomial experiment? Binomial experiments are random experiments that consist of a fixed number of repeated trials, and these trials are needed to be independent with each other, which means that the result of the other trial does not affect the result of the other. For example, we have tossing a coin 10 times, at the same time we are rolling a die 10 times. When we toss a coin, it does not affect the result that we might observe from rolling a die. There are certain requirements for us to say that a random experiment is a binomial experiment. So first we have a random experiment must have a fixed number of trials. So since we are dealing with discrete random variable, and discrete means that it has a certain limit. So that's why it should have a fixed number of trials. The second one will be each trial must be independent of the other. So as I said earlier, the other experiment and its result will not affect the other experiment. The third one will be each trial has just two possible outcomes called the success or the outcome of interest and failure. So, for example, if our experiment is tossing a coin 10 times and we are interested in the outcome of heads, then um, every heads will be counted as our success and tails will be our failure. Then this will be a binomial experiment since the 10 trials are independent and the probability of success is one half of each of the 10 trials. And then finally, there is a constant probability of success for each trial, the complement of which is the probability of failure, sometimes denoted as Q is equals to quantity 1 minus P quantity. Of course, when we are doing an experiment, there are certain probability that our desired outcome will be observed, and on the contrary, we also have the certain probability of failure that our desired outcome will not be observed. Let's all have these random experiment examples, binomial or not. The first one will be a fair coin is flipped 20 times. X represents the number of heads. So this experiment is a binomial one because X is binomial with N, which is the number of trials, 20, and then P, which is the probability of success, which is equals to 0.5. Letter B. Roll a fair die repeatedly. X is the number of rolls it takes to get a 6. So, this one is clearly not a binomial because X is not binomial because the number of the trials is not fixed. So we have discussed that in order for us to distinguish or to say that the experiment is a binomial experiment, it should have a fixed number of trials. And then for the last one, you roll a pair die 50 times. X is the number of times you get 6. So this one, on the other hand, is a binomial. So X is binomial with N is equals to 50 and P is equals to 1/6. Probability distribution of a binomial random variable. It is also called a binomial distribution. It can be thought of as simply the probability of success and failure outcome in an experiment that is repeated multiple times. Example, in a set of operated patients, so how many are the success and how many are the failures? We can express our binomial distribution in a tabular form. Here's an example of a tabular form for the probabilities of getting 0, 1, or 2 heads when we toss a coin with a certain number of times. Aside from using tabular form, we can also express the binomial distribution in a graphical form. Here's an example of the graphical form of the probabilities of getting 0, 1, or 2 heads when we toss a coin in a certain number of times. We also have the mean and variance of a binomial random variable. So we have the formula for the mean of the expected value, which is equals to the number of trials multiplied by the probability of success. And then we also have the formula for the variance, which is equals to the number of trials times the probability of success times the probability of failure. Let's have our sample problems. So example number 1. Jim makes 60% of his free throw shots. What is his expected shot if he is given the 5 free throw shots in a game? So we have the given n as the number of trials, which is equals to 5, p, the probability of success, which is equals to 0.60, and q, which is the probability of failure, which is 1 minus p, so it is equals to 0.40. And remember, our formula for our mean is equals to the number of trials times the probability of success. And we have 5 times 0.60 is equals to 3 shots. We can interpret the mean as, therefore Jim is expected to make 3 shots if he's given 5 free throw shots in a game. Example number 2. Anissa has an excellent reputation as a sales lady. She can sell bags of ice cubes in Batangas 92% of the time during summer. Calculate her variance given 400 bags of ice cubes that she needs to sell in Laurel. We have the given n is equals to 400, p is equals to 0.92, and q is equals to 0.08. Then, our formula for variance. Variance is equals to n times p times q. So we have 400 times 0.92 times 0.08, which is equals to 29.44. For the interpretation of our variance, therefore, Anissa is expected to sell 368 bags of ice cubes in Laurel with a variance of 29.44 bags.